There's one last thing from this section that I'd like to cover. I don't want to make a huge deal of it, but I at least want to talk through it briefly. It's this thing called Rawls' theorem. And here's what Rawls' theorem says. It says if I've got some function that's continuous on an interval, so let's pick a closed interval, a, b, and if my function is continuous on this interval, and the value at a and the value at b are the same thing. So let's write this out. If my function is continuous on the interval from a to b, and f of a equals f of b, and it is, that value, I'm claiming are exactly the same value, then somewhere between a and b there has to be a c value where the first derivative at c is 0. Let's write that out. It sounds sort of cryptic when you read it in this fashion, but if you just think about it in plain English terms, it's not that bad. If I start at one value and end at one value, and it's a continuous function, no matter how I get from this point to this point, I have to reach a point where the first derivative is equal to 0. If I did a straight line all the way across, the slope of the tangent line of that function, well, the slope would be 0 all the way across. Or no matter how many peaks I did, I have to have at least one point, and maybe more than one, where the first derivative is going to be 0. That's all Rawls' theorem says. Very straightforward. And that wraps up section 4.2.